A multinational team of astronomers has sifted through images from the James Webb Space Telescope and found that massive galaxies featured in the early universe in greater numbers than anticipated. Their results add to a growing body of evidence for unexpectedly abundant early, high-mass galaxies that has led astronomers to reassess models of galaxy formation and evolution. As light travels across the expanding universe, its wavelengths shift toward the redder end of the spectrum in what is known as redshift. As a result, distant galaxies, which originally emitted ultraviolet and visible light, appear to us at infrared wavelengths. Thanks to JWST's sharp infrared vision, more than ever have come into view. The new study in the astronomical journal draws on two sets of JWST observations made in 2022 at both near and mid-infrared wavelengths. The researchers found 261 massive galaxies in those observations and looked at how their number changes throughout cosmic time. The team took great care to look only at galaxies whose central supermassive black holes aren't feeding. The light from gas flowing in toward those black holes can overpower the light from the stars, making galaxies appear more massive than they really are. The light from galaxies with quiet black holes, by contrast, comes almost entirely from stars. The researchers grouped the galaxies by their distance and found that the number of massive galaxies increases with cosmic time, in line with what galaxy formation models predict. That's because galaxies need time to grow massive, whether that's by merging with other galaxies or forming their own stars. But at great enough distances, that is, when the universe was less than 1.5 billion years old, there's a surplus of massive galaxies compared to what's expected. That the models break down in the early universe may not be very surprising, remarks Claudia Lagos, who wasn't involved in the study. After all, she points out, those models were designed to reproduce observations of the local, present-day universe, not the long-gone one whose redshifted light is picked up by JWST. Precisely why the results diverge from the models is unclear. The team behind the study proposes two possible explanations. The first is that early on, gas may have cooled and condensed into stars more efficiently than today. Modern star formation is a sloppy, wasteful process in which only a fraction of the available mass is transformed into stars. However, this may not always have been so. As Gerard Mark Voigt say, in today's galaxies, star formation is self-limiting because of all the energy it releases. But perhaps those limitations don't kick in until the universe is more than 1 billion years old. A streamlined conversion early on would have enabled some galaxies to swell to giant proportions, despite the overall cosmic conditions being very different back then. A second, alternative explanation is that the mass-to-light ratio of the distant galaxies that JWST observes is lower than in the local universe. Astronomers use this ratio to work out the stellar mass distribution of a galaxy, and from that a host of other properties. Knowing the right ratio is therefore key. The ratio is ultimately an estimate, though based on theories of star formation, one that is known to vary over time. It might need to be updated in response to these new findings. Lagos finds the team's suggestions very reasonable, while cautioning that their conclusions are contingent upon accurate estimates of the galaxy's masses. Were those to have been overestimated, that would completely wash out the tension with the models. To establish whether any of these interpretations hold water, further measurements are needed. The study's authors point to observations of galaxy clusters as one means of bettering our understanding of star formation efficiencies. What is apparent is that JWST, floating through space with its golden mirror like some giant cosmic sunflower, is continuing to push boundaries and keep astronomers on their toes. We are in a new era where all these exquisite observations are making us think very hard about what we're doing and what we truly understand about galaxies and structure formation, enthuses Lagos, which is very exciting